review both worksheets, elimination and substitution, but just the word problem part. I don't need you to write the word problem. I just want you to write down everything I write with this pen. So the work, the explanation, whatever I write with this pen, I want you to write. That'll be your first grade for the 9 weeks. This is the first time where one classwork is one grade, an easy one. I want to start you off on the right foot next semester. So copy everything I write down, submit it to Google Classroom, and you'll get your easy A for the beginning of the semester. That'll help with that test you took a couple of days ago. So let's begin. The first worksheet we're going to review is the elimination method section. There we go. The elimination method section. Now, on these questions, sometimes the two equations are going to be similar to each other. For example, if the word problem said, Kira bought hot dogs and soda for this much, Catherine bought hot dogs and sodas for this much. Those two equations are very similar. The only difference is who you're looking at to create the equation. But sometimes the equations are related but different. So number one is an example of that. Here's my advice. I recommend you follow my steps and the order in which I do it. I like to put the totals first. So if we read this word problem, the first total we run into is 16. There are 16 total animals. So we know that one of the equations is going to be equal to 16. Now, before I fill in the information on that equation, let's put the other total. The other total I see is 46 legs. So the other equation is going to be equal to 46. Now, each total represents a different thing, so make sure you put the information in the right equation. So for the total of 16 animals, there's only two types of animals, chickens and pigs. So I'm going to call chickens X, pigs Y. You don't have to use those letters. You can use C and P if you want. It's the same thing. Now, we know that between chickens and pigs, there's 16 total animals. So that's the first equation. 1x plus 1y equals 16. Now, in the second equation, it's a leg total. So all we need to add here is the amount of legs for each animal next to the appropriate letter or variable. So here, chickens, like any birds, I had that problem last period. All birds have 2 legs. So chickens have 2 legs. We represent it with 2x. Pigs have 4 legs. We represent it with 4y. Now we have a system of equations. System of equations just means more than one equation. Now, the goal is to eliminate one of the variables, because if you eliminate one of the variables and there's only one variable left, you can solve for that variable. And that's what we need to do. So, for example, how would you cancel a -6 with a +6? Same number, different signs. So that's going to be the goal for this over here. The goal is going to be to get these two numbers on the x to be the same, but with a different sign, or get these two numbers on the y to be the same, but with a different sign. So we ask ourselves, what's easier to eliminate, a 1 and a 2 or a 1 and a 4? I would say a 1 and a 2. Now, between both equations, the only one that needs to change is the top one, because the bottom one already has the number 2 on it. So we don't have to touch the bottom equation. We multiply the top equation by -2. Why negative? Because we need the signs to be different. That's the only way something can eliminate. So now when we distribute, our result is -2x, -2y equals -32. Now we can combine these two equations. 2x minus 2x eliminates. 4y minus 2y equals 2y. And 46 minus 32 is 14. Now we just divide both sides by the coefficient, which is +2, and we get y equals 7. Now we know that pigs are y. So we already know that pigs are 7. Now, how do you figure out how many chickens there are? By plugging in 7 for y in any of these equations. So x plus 7 equals 16. The only step to do to leave x by itself is subtract 7 from both sides. X equals positive 9. So that tells me there's 9 chickens and 7 pigs. Copy down all the work. All right. Now let's go to number 2. On number 2, it's a similar question. This is how I set up this worksheet. 1 and 2 are similar, 3 and 4 are similar, 5 and 6, and so on. So you can always ask for help on one of them so it can walk you through the steps on the next one. So on number 2, we're not doing these by ourselves. Remember, you're doing these with me. So on number 2, again, we have a total for animals and a total for legs. So our equations are going to be similar to the ones we did on number 1. X plus y equals 10. That's the animal equation. 10 total animals, only 2 types of animals, x and y. Now the next equation is going to be a leg equation, so it has to be equal to 36. But you can't just put x and y because x doesn't have one leg, y doesn't have one leg. There's a specific amount of legs for these animals. So rabbits represent x, and rabbits have 4 legs. Turkeys are birds, and all birds have 2 legs. So now we have both equations. 1x plus 1y equals 10, and 4x plus 2y equals 36. Now we ask ourselves the same question. What's easier to eliminate, a 1 and a 4 or a 1 and a 2? I would say a 1 and a 2. The top equation needs to be multiplied by negative 2. If you do that, you get negative 2x, negative 2y equals negative 20. Now you get to see the purpose of multiplying that whole equation by negative 2 in order to get minus 2y in the bottom so that the y's eliminate. Now we put together the other two pieces. 4x minus 2x equals 2x. And 36 minus 20 is 16. Now we divide both sides by the coefficient and get x equals 8. So we know there are 8 rabbits. Now let's do the turkey amount in our heads. If there's 10 total animals and 8 of them are rabbits, how many are turkeys? 2. Because total is 10 animals. So now we have the amount of animals in the barn. Each animal in the barn. All right, now we move on to number 3 and 4. For number 3, it says find the value of 2 numbers. Now, we don't know what the 2 numbers are, but what we do know is that the numbers have to be different because they're talking about 2 numbers, 2 different numbers. So we're going to give it 2 variables. The first number, let's call it x. Second number, let's call it y. Now, the word sum means addition. Is means equals. So now we have our first equation. X plus y equals 12. The sum of x and y equals 12. Now the second equation is going to be similar. The second equation is going to be similar, but it says difference instead of sum. Difference means minus, so we're going to put x minus y equals 4. Now we have two equations. Now, in this case, you don't have to multiply any equation by anything because already we know that 1y minus 1y eliminates. So we can already go to step 2, combine these equations. X and x is 2x. 12 and 4 is 16. Now you can divide both sides by the coefficient and we get x equals 8. Now you can plug in 8 for x in any of those equations. I'm going to plug it into the first one. 8 plus y equals 12. The only step to solve this equation for y is subtract 8 on both sides. We get a y value of positive 4. So now you can always double check your answer. Sum means plus. Does 8 plus 4 equal 12? Yes. Difference means minus. Does 8 minus 4 equal 4? Yes. You can verify your answer very easily. All right, let's move on to number 4. Similar to what we just did. But this one starts with the word difference instead of sum. So the top equation here is going to be x minus y equals 3. And the bottom equation is going to be the sum equation. X plus y equals 13. Now, I'm sure you can get the calculator, start guessing numbers, and end up guessing the answer correctly. I have no doubt all of you can do that. But that takes a lot longer than learning the steps to solve this. Negative y plus y eliminates. X and x is 2x. 3 and 13 is 16. Now we can divide by the coefficient and we get x equals 8. Now you plug in that 8 to any equation. So 8 plus y equals 13. Only step I got to do to solve this is subtract 8 from both sides. That leaves me with y equals positive 5. So my two numbers are 8 and 5. Do they add up to give you 13? Yes, they do. Do they subtract to give you 3? Yes, they do. So we did it correctly. Pretty simple. These are pretty simple. All right, now number 5. On number 5, this is a question where the two equations are going to be similar to each other. It's not one is legs, one is animals. In this case, the difference is only the day. The first day is going to make up the first equation. The second day is going to make up the second equation. So on the first day, they sold 3 adult tickets and 1 student ticket. So let's give a variable to each and create the equation for the first day. 3x plus 1y equals $38. That is the equation for the first day. Now, for the second day, they sold 3 adult tickets and 2 student tickets, and $52 was made. So now, before I show you how to solve this, or remind you how to solve this and get the value for x and y, I want you to use your common sense. Look at day 1 and look at day 2. What's the only difference in sales between day 1 and day 2? You could read the what? The total amount of tickets he sold. Yes, but be more specific. You have 3 adults on top, you have 3 adults on the bottom. But on the first day, only one student ticket was sold. On the second day, two student tickets were sold. So again, you look at both. The only difference between what it says on the first day and what it says on the second day is one student. Does everyone agree? That means if I subtract 52 and 38 to get 14, that should be the price for what? One student. Now, obviously, you don't have to do it like that. I'm going to solve it, and we're going to verify if we thought correctly at the beginning. So, what's easier to eliminate, a 3 and a 3 or a 1 and a 2? A 3 and a 3. The numbers are already the same. So, all you have to do is multiply the equation by -1. I can't multiply by a bigger number because then that 3 would not be a 3 anymore. So, you just multiply by -1. When you distribute, you get -3x minus 1y equals -38. Now we combine the equations. 3x minus 3x eliminates. 2y minus 1y is 1y. And 52 minus 38 is 14. What do you know? Student price is 14, just like we had guessed. Now, to find out the adult ticket price, you need to plug in 14 for y in any of these equations. I'm going to use the first one. 3x plus 14 equals 38. Now, let's solve this two-step equation. Subtract 14 from both sides. And divide by the coefficient, which is 3. You get x equals 8. Now you know how much adult tickets cost, $8, and student tickets are 14. Any questions? All right. So let's skip number 6 because it's the same thing as number 5, and I want to get to the substitution worksheet. I have to get to that worksheet. It's more important, I think. All right, so number 7. Not that it's more important. It's just a little harder to learn than elimination. Elimination, I think, is the easier one to remember. Substitution takes a little more thinking, a little more labeling of the words that you're reading. So number 7 here. This is a situation like the animal situation where the two equations are not going to be similar to each other. They're going to be related, but they're going to be about different totals. So here it says there's a coin jar that contains only quarters and dimes. So let's start off by giving quarters and dimes a variable. If you want to use Q and D, that's fine with me. I use X and Y. So now we know that there are 19 coins in total. So that is a total. That goes on one side of the equal sign. Now that is the total amount of coins. There's only two types of coins, X and Y. So that's our first equation. X plus Y equals 19. Now we create the second equation. The second equation is value-based. Look at the total here, $2.95. So now we know that this equation has to be value-based. So we know that quarters are 25 cents. So we need to put 0.25x plus dimes are 10 cents. So we're going to put 0.10y. Now we have both equations. Write them down. And I'm going to get off of the screen and show you something. Was it 19 coins? 19? All right, so there's a reason why I'm showing the same system twice. So I'm just going to show you two different ways you can solve this. They're both elimination method, but this is just to show you that no matter which route you take to solve it, we'll get the same answer, even though we took different routes to solve it. So Catherine can want to cancel the x's. I want to cancel the y's. We both end up with the same answer, so it doesn't matter. Okay? So this is what I want to show you because people tend to get confused when there's decimals. The first thing I can show you, which I think is the easiest, is 25 cents. That automatically makes you think of money, right? Now, how many quarters are in a dollar? 4 quarters. So if I want to turn this 0.25 into a 1, all I got to do is multiply it by 4. But that would be the same sign, so we got to add what to that 4? A negative. So now when you distribute, negative 4 times 0.25x is negative 1x. Negative 4 times 0.10y is negative 0.40y. And negative 4 times $2.95 is negative $11.80. Now write the other equation right below this one so you don't get confused. And let's combine here. So negative 1x plus 1x eliminates. Negative 0.40y plus 1y is 0.60y. This is all calculated work. You should all have calculators, especially when you're working with money. And now negative $11.80 plus $19 is $7.20. Now all we got to do is divide both sides by the coefficient, which is 0.60. And that gives me a y value of 12. Any questions on how we got the y value? So we know that 12 is dimes because y was dimes. X was quarters, right? Now we can plug 12 for y into this equation and solve. Or use our common sense. 12 plus what would give you 19? 7. So that tells you there's 7 quarters and 12 dimes. Any questions? Now, before we move on from it, copy that down. I'm going to show you another way to cancel. So if you can please bring your eyes up here. Now, we decided to multiply the quarters by negative 4 to make it a negative 1 and cancel, right? But a 1 is a very special number. 1 times a million equals a million. 1 times caceres equals caceres. Like anything times 1 equals itself. So you can go the other way around on this question. What would we multiply to 1 to make it a 0.25? 0.25. And you can just, don't do it, don't actually do that. You can distribute that, solve it, you'll get the same answer that we did multiplying by negative 4 instead. What's easier? I would say multiplying by negative 4 is easier than multiplying everything by 0.25. But like I said, you get the same answer, so it's okay. You with me? right? Okay. Okay, we're going to skip the hot dog questions and go straight into the next worksheet, substitution. So now label this substitution, word problems, like this, substitution, word problems. What? Elimination is the one we were just doing. And the difference is that in elimination, both equations are going to be in standard form, like x and y on one side, constant on the other. On these questions, it's not going to end up that way. And if it does, you're supposed to get the variable by itself in order to substitute it and solve. Now just title it and pay attention. Okay, so my advice, definitely on substitution, you want to label the words right where you see them. Why? Because if you start writing your answer from the beginning and you read a word, for example, like more than, and you don't remember at the beginning of the year where I taught you that more than is an order switcher, then you're going to get the wrong answer. So, anytime you see the word than, more than, less than, bigger than, smaller than, anything with than, anything in comparison, is going to change the order of those things. So, this is what has the word more than in it. 9 more than 8 times a number. So I know when I write that as my answer, the 9 is going to be after the 8 times a number. I have to switch the order on that part. So let's begin. 11 times one number. So 11 times one number. Let's call it x. Is means what in math? Equals. 9 is 9. More than means plus. 8 times another number. Can I put x there? No, because it's another number. It has to be y. It could be z. It doesn't have to be y, but next letter in the alphabet is the easiest, obviously. So now we have our first equation right here, but we can't forget to switch the order where the words more than were. So here we got 11x equals 8y plus 9. Now, let's read the second part. The first number, which is x, because that's the first number we used, minus 4 means equals half of the second number is half y. Now, the goal for this lesson, the goal in this lesson is to get a variable by itself and then substitute into the other equation, right? But look at the first equation because you have to make a decision here. Is there a variable by itself on any of these equations? No. So you have to make the decision. Which variable am I going to try to get by itself? I mean, which equation am I going to try to use to get a variable by itself? Let's check the purple one. If I wanted to get x by itself here, what would I have to do? Divide by 11. If I divide 8 by 11, will I get a clean number? No. If I divide 9 by 11, do I get a clean number? No. So don't use the top equation to isolate a variable. That's not the smart way to do it. Look at the second equation. There's only one step needed to leave the x by itself. What's that one step? Plus 4 on both sides. If I do that, now I have x by itself. X equals 1/2 y plus 4. Now I'm ready to substitute. Because x is by itself here, we can plug in 1/2 y plus 4 wherever the x is in the other equation, which is right there on the 11. So let's set it up. 11 times, instead of x, you're going to put 1/2 y plus 4 equals 8y plus 9. Now, let's solve this and get the y by itself so we can get a value for it. 11 times 1/2 y is 5.5y. 11 times 4 is positive 44. Bring everything else down. Now, we can't solve for y if y is on different sides. So the next step is getting the y's to the same side. Which one's smaller, 5.5 or 8? 5.5. So let's move that one so we don't have to work with negatives at the end. Minus 5.5 y minus 5.5 y. That leaves me with 44 equals 2.5 y plus 9. Let me get more space here. So 2 more steps and we solve this. We're trying to get the y by itself, so we need to get rid of the 9 by subtracting 9 from both sides. That leaves me with 2.5y equals 35. And now you can divide both sides by the coefficient, which is 2.5. That leaves me with y equals 14. Y equals 14. So we got one value. Now, all we need to do to find the second value is plug in 14 for y in any of these equations. So let's plug it into this one. This is the easiest one to use. X equals 1/2 times y plus 4. Instead of y, what are you putting there now? 14. Now we can solve it. What's half of 14? 7 plus 4, 11. Copy down the work. Ask me any questions if you have them, please. So the rest of the problem says, if the perimeter is 80, what are the dimensions of the rectangle? So we know that perimeter has a formula to it. The perimeter formula is twice the length, well, let's put it over here close to the other one, twice the length plus twice the width. That's the formula for the perimeter. And since they give you the perimeter, instead of making it equal to P, make it equal to 80. Now, in both equations, on the top one, W is by itself. So now we're going to plug in L plus 12 for W in the other equation. So we set it up. 2L plus 2 times L plus 12 equals 80. Now we distribute there, collect like terms. So we have 2L plus 24 equals 80. Now we combine like terms and we get 4L plus 24 equals 80. Now we subtract 24 from both sides. It leaves us with 4L equals 56. And you divide both sides by the coefficient and we get L equals 14. So we know the length is 14. We're still missing the width. How do you find the width? By plugging in 14 for L in any of those equations. So if we plug it into the top one, W equals 14 plus 12. That's 26. Yeah, L. Make sure you copy it down. All right, number 5. On number 5, it says the length is. So we already have L equals at the beginning of the sentence. 5 more than twice the width. Now, before you actually write your answer at the bottom, label these words. 4 more than is plus, twice the width is 2 times W. Now, because you see the words more than, we got to switch the order of those two terms. So we have L equals 2W plus 5. I switched the order of the 5 and the 2W because of the word. Now we keep reading. Perimeter is 28. The perimeter is 2 times the length plus 2 times the width, and the perimeter is 28. Now we can plug in 2W plus 5 for L in the other equation. We could do that because L is by itself. Now let's set it up. Instead of 2L, you're going to put 2 times 2W plus 5 plus 2W equals 28. Now let's distribute and then collect like terms. So that gives us 4W plus 10 plus 2W equals 28. Like terms, 6W plus 10 equals 28. Two more steps to get W by itself. Subtract 10 from both sides. And then divide by 6. Divide by the coefficient. And we get Y equals 3. So the width equals 3. Now, we plug in 3 for W in any of these equations. The top one's easier. 2 times 3 plus 5. That would be 11. So we know L equals 11. Any questions? All right, so everybody pay attention to the screen. All right, so I mean, I'll go back and forth for you guys while I'm here, but what I want you to do now is Z1, which is the vocabulary for this lesson that's coming on Thursday. You with me? So, probably Friday, not Thursday, but this lesson is going to be Friday. Z1 is the vocabulary for that. So all you need to do is get Z1 to 100. The three people last class, all of them got to 100 pretty quickly. But you're going to have questions, and the questions are related to this. So let me just show you these 2 pages. No work. Just show you the 2 pages so you know what they're asking. All right. So on the first page, types of polynomials. Whenever you see these as your answer choices, linear, quadratic, cubic. Whenever you see those as your answer choices on the IXL, all you're doing is looking for the highest exponent. The highest exponent is 1, you call it linear. If the highest exponent is 2, you call it quadratic. If the highest exponent is 3, you call it cubic. If it's 4 or more, you put none. Everybody with me on that? On the next page, terms must be separated by a plus or a minus. So if you have, for example, A, B, C, do you see a minus? Do you see a plus? That means this is one term. You with me? Even though it's 3 letters, it doesn't matter. It's one term. But here, you have a plus, and a minus. Those separate different terms. So how many terms do we have here? 1, 2, 3, 4 terms. You with me? Now, in terms of terms, if you have one term, it's called monomial, because mono means one. If you have 2 terms, binomial. Bi means 2. If you have 3 terms, trinomial. And if you have more, put none. You with me? This is it, right? Now, I do want to show you degree, right? So, the degree is adding all the exponents together. So the degree of this term right here, 4 plus 3 is 7. That's the degree of something. Just count the exponents on that term. You with me? Now, if let's say it's a polynomial like this, the degree of a polynomial is just the highest amount of exponents on one term. How many you got here? 3 and 3 is 6. 4 and 1 is 5. And 2. Which one's higher? 6. So the degree is 6. You with me? It is that simple. That right there will get you to 100 on the polynomial IXL because it's just vocabulary. You with me? All right, I'm going to put that on Google Classroom.